Dr. John, back with another video on geometric sequences and series. This video has only one problem, and that's this one here. Looks a little bit more complicated. Here we have a geometric sequence, at least it looks like one, 6, 42, 294, 2058, and then this giant number. I've listed the giant number in the bottom there so you can read it better. And they're asking, how many terms are there from here to here? Which number of terms is this? If this is the first term, second term, or if this is the n number, what n number would this be? By n number, I mean this. Here's the general formula, T of n, where n is this number, 1, 2, 3, whatever number that is equal to the first term, or a, and then r, the common ratio, n to the minus 1. We use n to the minus 1 because if you put 1 in here, n is equal to 1, this term becomes r to the 0, so it's just the first term. T to the 1 is equal to the first term. We are wondering what this n is that will give us this giant number here. The way that you would normally do this is you would put this number in here and try to solve for n. I'm going to do this in pieces here. Let's just call this giant number a, just so we don't have to write the whole thing up here. So I'm going to put a is equal to T1. We know the first number here, 6, and then a common ratio. What's the common ratio? What do you multiply by 6 to get 42? Well, that would be 7. Does the same thing work if you take 42 times 7 to get this? Yes, it does. If you do this times 7, do you get this? Yes, you do. So 7 is the common ratio for all of these terms. So that would be r is equal to 7. T1 is equal to 6, and r, the common ratio, is equal to 7. So let's plug that in here. 7 to the n to the minus 1. Now this, of course, can be rewritten here if you want to. 7 to the n minus 1. This is the same as 7 to the n over 7 to the 1. So we just made this minus 1 here. That's how you handle powers. So you can do this. You can divide this up this way. And 7 to the 1 is just 7. I'm going to put this underneath the 6 here. So now we have this giant number a is equal to 6 over 7 times 7 to the power n. If I wanted to solve that, what I would do is I would take a, multiply it by 7, divide by 6. That's just taking care of these things here. Finding out what number that is. It's going to be a number very close to this. And then, using my calculator, I'm going to punch in 7 times 7 equals. Most calculators will work like this. You'll go equals, you'll hit equals again. So 1 equal will give you 7 squared. 2 equals will give you 7 cubed. 3 equals will give you 7 to the 4th. So continue onward till you get this number here that you've concocted here, that you've figured out here. A to this 8 times 7 divided by 6. Once you've found that number, then you'll have found which of these b's here. And then once you've figured it out, so I did that in my calculator. I punched in and I got b is equal to 11. Then I went back to my calculator again and I sort of tried to see if I could solve everything here. So I took b and I took n minus 1, which is 10. And then I took my number 7. You can use your calculator, 7 to the power 10. I did that and then multiplied by 6 to get this number again. That's how you double check. On an exam, of course, you just plow your way through it, get it as fast as you can, as simply as you can, then continue on, finish your exam. Once you're confident with everything, come back and double check some of your answers just in case you made a mistake. I hope that helps. I'll see you in the next video. Bye-bye.